Okay, question 9. What is the force of a 3.6 meter segment of a wire which hangs at 38° east of the vertical and carries 12 amps down the wire if it is an eastward magnetic field of 2.3 Tesla? So we're going to slow down a little. We're going to break down the problem bit by bit. So we have to find the force on a 3.6 meter segment of a wire. So we have the length of the wire equal to 3.6 meters. And we need to find the magnetic force that is applied to it. So that's the unknown. Now, this wire is hung at 38° east. So what that means is that if this is the vertical, then the wire is hung at 38° east. And 38° east will be going this way. Remember, here is the compass. So this is east and this is west. Now, this wire is in the magnetic field, right, of 2.3 Tesla, and the magnetic field is heading eastward. So what that means is that, just going to draw multiple magnetic lines in here, magnetic field lines, okay? And they're all pointing east. And the strength of the magnetic field will be 2.3 Tesla. Now, the wire carries a 12 amps current, so that would be equal to 12 amps. That's current in the wire. And we need to find the magnetic field that is applied to the wire. Now, we have a formula for this, and there is only one formula, so we don't have to think too hard. So the magnetic field would be equal to current multiplied by L, multiplied by B, and then multiplied by the sine of angle theta. Now, remember that we have I, we have L, right? And in correct units, so we don't have to worry about this. And actually, I'm going to substitute I by 12, and I will substitute L by 3.6, and it's in meters. And I will substitute also the magnetic field of 2.3 Tesla here. And we have to stop by the angle theta to figure out what the measurement of it is. Now, we have to know what theta represents. Remember that angle theta is the angle made between magnetic field lines and the wire, or the current in the wire. Now, whenever, since the wire is, the current is going eastward, so it's going this way, right? And magnetic field is going this way here, right? In order to find the angle made between magnetic field and the current, we need to place them tail to tail. So, and the way we do this, remember, this is the tail, this is the head of the magnetic field line. And we don't need all the field lines in here. We can delete them if you wish. You can delete them if you wish. So I'm going to bring the magnetic field line with the tail at the tail of the wire. So you can either do this, right? Or you can leave this where it is, and you can bring the tail of the wire right at the magnetic field line. It's the same thing. I think that it looks a little bit prettier to bring the magnetic field line in here. It's easier. And then now you can tell that the angle made between the two would be equal to, this entire thing is 90 minus 38. So, and 90 minus 38 is 52 degrees. So the angle theta in our case would be 52. And all you have to do is simply use a calculator and then punch the numbers in. Don't forget to state the answer to correct significant digits. And we have 12 times 3.6, and then multiplied by 2.3 and multiplied by sine of 52. Calculator has to be in degree mode. And that is 78.296. And this is going to be in newtons. You see that we have 2 sig figs in here. So we're going to say that the magnetic force is 78 newtons. And Is it asking us for the direction? Well, it doesn't actually, but we know that force is a vector quantity, so we need to know what the direction of the force is. For this, you're going to use the FBI rule. So this is the direction of your this is the direction of your current. That's where your pointer is going to go, and this is going to be the field. So it seems that the force will be toward you, so it's going to point at you. All right. So out of the paper. All right. And thank you for learning with me, and I hope this made sense. Bye for now.